Solving radical equations. Solve the given radical equation. Check all proposed solutions. Here we have the square root of 4x plus 37 equals x plus 8. When we have a radical on one side of the equation, we can square both sides to get rid of the radical. When we square the left side, we're left with the expression underneath the square root bar. So this becomes 4x plus 37 equals x plus 8 squared. Now x plus 8 squared is the same as x plus 8 times x plus 8. So we have 4x plus 37 equals, and we'll multiply x plus 8 times x plus 8 to find this polynomial. You can do this using the FOIL method. First, outer, inner, last. This tells me which terms to multiply in which order. X times x gives me x squared. X times a positive 8 gives me a plus 8x. 8 times x gives me a positive 8x. And 8 times 8 gives me a positive 64. Next, we can simplify this polynomial by combining like terms. 8x plus 8x is 16x. So my polynomial on the right side is x squared plus 16x plus 64. And this equals the 4x plus 37. Now I have a quadratic equation because my highest exponent in this equation is 2. In order to solve the quadratic equation, let's move all terms to one side and set the equation equal to 0. I'm going to subtract 4x and 37 from both sides. On the left side, I have 0, and that equals x squared. I'll combine my x terms. 16x minus 4x is positive 12x, and 64 minus 37 is a positive 27. Now I have x squared plus 12x plus 27. We will factor this polynomial into two sets of parentheses and set them equal to 0. Since there isn't a coefficient in front of my x squared term, I know that the first position in each parenthesis is x. Next, we can look at our last term, which is a positive 27, and list the factors of 27. We have 1 times 27 and 3 times 9. Now we want to choose a pair of factors that when added together give me a positive 12. So that means I'm going to choose the 3 and the 9 because 3 plus 9 is 12. I can put a 3 in the first parenthesis and a 9 in the second. Since the middle sign and the last sign are both positive, I know that both of my signs in the parentheses will be positive. You can always check this by multiplying it out to make sure that you get the original polynomial. Now that I've factored this, I can set each factor equal to 0 and solve. X plus 3 equals 0. To solve for x, subtract 3 from both sides, and I get x equals negative 3. In x plus 9 equals 0, subtract 9 from both sides, and we get x equals negative 9. Now we are not done. In all radical equations, we must check our solutions to make sure that they work in the original equation. Here we have the original equation. We want to plug each of our values for x into the equation to make sure that they work. First, we'll check x equals negative 3. So I have the square root of 4 times negative 3 plus 37 equals negative 3 plus 8. This becomes the square root of negative 12 plus 37 equals 5. Negative 12 plus 37 is 25. So the square root of 25 equals 5. When checking the solution, always take the positive of the square root. We will not deal with the negative of the square root. So the square root of 25 is going to be positive 5 only. Positive 5 equals positive 5, so we know that x equals negative 3 is a solution to our problem. Now we're going to check x equaling negative 9. So we'll plug negative 9 into our original equation and see if the left side equals the right side. The square root of 4 times negative 9 plus 37 equals negative 9 plus 8. This becomes the square root of negative 36 plus 37 equals negative 1. The square root of negative 36 plus 37 is the square root of 1. And remember, when taking the square root of a number, when checking your solution, you always take the positive number. So the square root of 1 is going to be positive 1. Now, positive 1 does not equal negative 1. So that means that x equaling negative 9 is not a solution to our problem. The only solution we have is x equals negative 3.